So the AREDN project's been around in its current form. The AREDN project has been around 12 years at this point, I think, and I think there's a previous iteration before its current version. And it was really started by a bunch of hams who wanted to have a better way of exchanging large amounts of data during an emergency. You know, they're all used to using like walkie-talkies or other forms of radio, but they wanted to be able to send pictures, they wanted to be able to send short videos, they wanted to send more complex information when an emergency was happening, and how were they going to do that, you know, because they couldn't really do it using the tools that they currently have. So they decided the way to do this was using you know, different kind of radios to be able to push this kind of information around, and AREDN sort of came out of that vision. So although I'm involved in AREDN a lot at the moment, I am by no means the first, you know, the first developer involved in this. There's a long chain of developers who've worked on this software, worked on this project for many years now. Their realization, I think, was the fact that the modern world is built on the internet. You know, all communications that we do now pretty much goes over the internet, whether you know it or not. And their question was, well, in an emergency, the internet's not going to be there, or it might not be there. If it is there, it's going to be co-opted by by the police, by the other services. You know, what will we be able to do when that's not there? What services won't work? What services we need to provide? So they wanted to build, you know, essentially, they wanted to build an amateur radio internet to let that kind of stuff work. So that was sort of the inception of what they needed to do. They needed a way of moving a lot of data, but they wanted that way of moving that data to look like the internet, because people were familiar with the internet. People are familiar with web browsers and voice over IP phones and whatever it could be. People were familiar with how all that stuff works. They just wanted to make sure they had one that would work if an emergency happened and the normal internet wasn't available to them. So they looked at what was available to them, what amateur radio spectrum was there that they could utilize, and there are really sort of 4 bands that they looked at: the 900 megahertz band, the 2.4 megahertz band, the 5.8 megahertz band, and the 10 gigahertz band, and the 10 gigahertz band. And the 2 in the center, you'll notice, are basically where home Wi-Fi is living. Most of it used to be 2.4 gigahertz. Most of it now is 5.8. But this is there's a certain amount of shared spectrum there that they could use, because amateur radio could use it, and they could use it at higher powers, and certain parts of that spectrum would for their use only. So they could also have a certain amount of clear space that they could use. And they were sort of aware that hardware exists that you could just buy off the shelf. That works in that band. So why don't we take this hardware that exists, that's used in the home, tweak the software a little bit, and make it work for amateur radio? And that was basically their plan. That's basically what they did. Off-the-shelf hardware, their own custom software coming together to build like an amateur radio network, if you like. How hard can that be, right? Here we are, 12 years on. So AREDN itself is a bunch of things. AREDN, I mean, Dave talks about our local piece, but AREDN is a non-profit that's been around at least 12 years. Has a board of directors that manage what happens with the name, with the software and stuff. And I just volunteer for these folks. But essentially, it's free software. In other words, you can go onto the internet, onto a site called GitHub. Everything is there. Everything that's ever been done is there. They don't delete anything. Nothing's deleted. So you can see, you can go back and look at AREDN from 12 years ago. You can go back and look at AREDN from this morning when stuff might have been changed, right? It's all there. Every version of the software we've ever made can be downloaded from the web servers. You know, everything is free. Everything's open. It's open to anybody to change, to do anything with. Nothing is commercial in any way. And that's important to them. And it's sort of important to me. My entire career has been open source software and that kind of thing. And working in the domain of something that anybody can use and anybody can use for free is very important to everything I do and very important to the AREDN folk. But So now you've got a bunch of software that's free, but you've got to make it easy to use. If you make a bunch of really complicated software with lots of like buttons you have to press, knobs you have to turn, no one is going to use this stuff, right? You need it to be simple. You need someone to get a radio and some software, put it together, stick it on the roof of their house, and it work. And that's hard because everyone's roof of the house is different. All these radios are different. Everyone's environment is different. The level of expertise people have in these for ham radio and to a certain extent, internet sort of networking is vastly different. So trying to make something that works for most people is an interesting problem, which is great because interesting problems are fun. But you want to make it simple for people as much as you possibly can. And the other thing they sort of knew, I mean, we're talking about we had that list of bandwidths. Spectrum we're looking at earlier. It's all microwave, and it's all point to point. It's all trees are not your friend, mountains definitely not your friend. So we're not talking about putting a radio up on a hill and talking to 1,000 people. You're talking about putting a radio that can talk a few miles if you point it in the right direction. So when you're talking about an AREDN, you're talking about building lots of people getting involved, lots of people putting radios on their houses, on their towers, on their hilltops to build a network out where one radio is building off another radio, is building off another radio. So it becomes like a community effort to build one of these networks. And that's really what AREDN is trying to use this software to do. And by building that out, you eventually build a network that everybody can use. If they can just get to one point in it, they can use all of it to do whatever they need to do. So people in here have maybe heard of Meshtastic or Meshcore. They're quite popular right now. They are examples of mesh networks. And a mesh network is one where rather than having one radio talking to everybody, you have one radio that talks to another radio, that talks to another radio, that talks to another radio. And by doing that, the message starts in one place and it gets to where it needs to go. There are lots of ways to build these. And AREDN builds this network in a very different way to how, say, Meshtastic might build this network. But conceptually, it's the same thing, right? You are putting up a bunch of radios which talk to each other to pass messages from where they start to where they need to go, and then back again. So that's this little picture up here is basically that an example network where the radios are connected together and they work out the best path to connect together from the many paths that are available to them. Because you want to build the most optimal way of getting information across this network, because then it's fast, it's efficient, and then you're not wasting bandwidth. And a network like Meshtastic does it by just broadcasting to everybody and then rebroadcasting to everybody. ARM's a little bit more clever about this. It works out how to get the message to the right place from the best path. So it's much better use of spectrum, much faster, and much more efficient. So that's a sort of very rough overview of what ARM is trying to do. We're trying to build a network from a bunch of individuals putting radios on their towers. But what hardware do we use? And at the beginning, I talked about the fact that we wanted to take. We don't want to build stuff. Basically, we don't want people to have to solder boards. We don't want people to have to buy things and assemble them and all this kind of stuff. It's fun, but we don't want people to have to do that because we want to make this simple. So so the AREDN folks in the beginning started out with some very basic radios they could get, but from that point, an entire industry sort of blew up. Was created called WISPs, which is the wireless internet service providers. So back in the day, you just used to have to buy a home router to do this. Now you can buy a device with a dish, which you can put on your house from an outfit like Ubiquiti or Microtik. So all this hardware is really easy to get hold of, and that makes it cheap. This picture is one of my sort of go-to devices. This is a Microtik HAP AC2. It's a little 5-port router. You might sit this on your desk inside your shack. plug your laptop into it, and that will give you access to the AREDN network. This little thing contains a radio, which is like good for inside your shack. Perhaps not the best radio if you want to put it on top of your house and talk to other AREDN nodes in your neighborhood. For something like that, you want a radio like this. So this is a couple of examples. The top one is the Ubiquity radio. It's about $79, I think. The one on the big dish on the left is about a similar price device. It comes from Microtik. It's, again, about 79 bucks. And the little square thing down to the bottom right, I think that's like 60. I mean, this stuff is dirt cheap, right? Which is nice because it allows people to like get involved without having to like break the bank or invest a lot of money into this stuff. You know, that means the build quality of this stuff is not amazing, but we've had stuff up for years that's like costs $80 and works really well. So, you know, the stuff lasts. So, you know, these are the kinds of radios, and as I noted at the bottom, these are the kind of radios we use, but there's like at least 70 versions of these radios now that we support. A lot of them are very similar. You know, you might get a bigger dish or a smaller dish or a different manufacturer that basically builds a very similar radio. But Ubiquity and Microtik are basically the main brands that we recommend. There are a few others too, but these are the sort of main brands recommend. And I say for $100, you can buy a nice radio that will go on the top of your house and point, you know, somewhere around here. I mean, there's an AREDN radio on top of this building. You can point here. So we have a whole bunch of AREDN radios up on San Bruno Mountain. If you can see that, you can probably connect. So you might buy one of these radios for like $100 and just point it to that mountain, and you're connected to the AREDN network. This is part of the AREDN stuff in my house. It's only one of the poles, but it gives you an idea of what the stuff looks like in the wild. So this is a 2-foot dish pointing across the bay. I'm in Berkeley, so it points across the bay up to Wolfback Mountain up in Marin, the Marin Headlands. And on the back of that is a Ubiquity radio called the Rocket, which is a nice little radio because it doesn't come with an antenna. So in this case, I paired it with a nice big dish to get a good connection across the bay. And I just inhaled a fly.
More tea.
It's not as good as tea. So this is my main connection into the from where I am into the AREDN network, which is this big dish. On top of that, you can see it sort of peeking out. Unfortunately, I cropped it off the photograph. Is a little bit of a horn antenna. So that's I think that's a 45-degree horn that I have up on further up the pole at my house, and that's for other people in Berkeley to connect to, so they can connect to me, and then of course my dish will take it across to the Marin Headlands. That site takes it down to a bunch of other places. I think it takes it over to San Bruno, and I think it takes it over to the Oakland Hills. So you know, that's my sort of connection into the world. But you know, so some people in Berkeley will point to me, and that's how they connect it as well. So as I say, it's a very cooperative and collaborative effort, and you'll get a lot of communications with people saying, "Hey, can you point something in my direction to try and get a better connection?" And you know, I personally, I'm always happy to try and help somebody else get involved. So if somebody wants me to point a dish at them, I will point a dish at them. My wife just ignores me. It's fine. Just don't fall off the roof. And we're good. It's the only rule. This is a sort of more serious installation, I suppose. This is up at the Oakland Radio Club up in the hills in Oakland. If you look up into the hills in Oakland, you see the KPFA tower, radio tower up there. That's where those folk are. This is sort of a tower next to it. So they have a whole bunch of stuff as part of the network. They have a dish that will cross the bay over to San Bruno Mountain. They have some local connections. So they have, for example, they have a connection now down from there to Coast Guard Island down in Alameda. They have a rather than having a dish, which is a point-to-point connection, they'll have a sector to provide service to other people down in the Oakland area. So they have some other people pointing up into there. And again, you know, they're basically providing a sort of backbone node that people can come up into, and it connects to the rest of the network. The stuff you would put on your house, much more like what Dave was waving around a minute ago.
So it's one of the little squares.
So you don't have to put a 2-foot dish on your house. A little square thing like this, which can be incredibly discreet, will get you what you need to do. It's just that you know how it is. You get more addicted to these things, and you buy more radios. Yes.
Oh yeah.
Does those help improve Wi-Fi internet connection also?
Does it help improve Wi-Fi internet connection? So
Explain that. You know,
so AREDN is its own thing.
flashing,
Sorry.
changing them from what they are.
So yeah. I mean, so it's a question. Does this help your internet at home, or is it?
Yeah. If I use that for a radio tower that I were to build at my home, would it also help with Wi-Fi connection? Because they work together.
So they're compatible, but so the idea of the AREDN network is not to provide internet service to the general ham community, although some groups do that, because whilst it has a decent amount of bandwidth, it doesn't have the same kind of bandwidth you might get from a fiber or from a Starlink satellite. I mean, you might be looking at 20 or 30 megabits rather than 100 or a gigabit. So it's a more limited resource. It's a big resource compared to a lot of amateur radio, but it's still relatively small compared to like a fiber that might come in from Sonic or Comcast. So it doesn't really help your home internet in that regard. It does. I mean, I'll talk a little bit about its uses later. But I can definitely see it in a disaster situation where standard internet is not there, because I live in Berkeley, right? We have fires in the hills. We'll have, someday there'll be a disaster where all the fiber will melt, and my internet is not going to work then. But the AREDN network hopefully will stay up, and somewhere on that network there will be a connection out to the rest of the world. So in those circumstances, I think it's entirely reasonable to use AREDN as an internet connection to the rest of the world. Good for, say, WhatsApp messages or something like that. Not great for to try and watch Netflix whilst this is going on. So I think it does that for you, but I don't think it's a replacement for your home internet in that regard.
Not for a replacement, but to improve if Wi-Fi is often slow.
Right. So not really, no. It's really its own separate thing and should be treated as such. So that's the sort of the radios, what you do with them, how you point them at each other. But you've got to build your network, and you've got to find people to point at, right? So maps are quite useful in this regard. This is my little bit of AREDN. This is where I live. I'm the sort of grey spot at the top of the map. This is in Berkeley, and this shows you some of my neighbors who are connected. We have the blue spot is up on one of the tall buildings on the UC campus. There's some radios up there. There's some cameras up there, so you can look at the view. The orange to the right is the Orca, that site I showed you earlier with the big tower with the dishes pointing across the bay. That's the Orca folk. And then the rest of this is just local hams in my area who are part of our little bit of our network in Berkeley. And they connect to each other. They connect to each other by other third parties. I mean, basically, that's my little part of the network.
Do the red and the orange and the black and the blue lines signify something?
They do, yes. So the color coding if you go to these maps online, there's actually a key. So the blue is 3 gigahertz radio. There's not much 3 gigahertz radio about anymore because the bandwidth has kind of been taken away. And the hardware is basically impossible to buy now, except on eBay for quite a lot of money for what you get. So mostly the 3 gigahertz stuff is disappearing. The orange is 5 gigahertz stuff. The red stuff is that's another topic entirely, but it's a different kind of radio stuff that mostly AREDN doesn't use but can. But it's sort of like connecting. It's the radios we use to connect the big sites up on the top of the hills. So it's big dishes and big powerful radios. And then the sort of gray dot, the gray dashes, I'll talk about a little bit later, but that's for people who want to get involved but can't put a radio on their house right now. What do they do? The gray dashes are representing their connections too, and I'll talk a little bit about that when we get to the software. This is a map of our local area. I didn't bring a map of all the other networks in the world. There are a lot of them. This is just the one from around here. And as you can see, it goes all the way down to Santa Cruz. It goes all the way up to Folsom, just outside Sacramento. It's not all radio. There are some cheats here where it's going across the internet to connect people together. But most of where we are, it's radio to radio to radio, which is connecting everything together. Some other groups do it differently. The group up in Oregon have a big network, but they have a very challenging sort of landscape, I suppose. And they have a lot less radio connecting their stuff together. They have pockets that are connected over the internet. The group down in Southern California have a much bigger network than we do. They've been doing this a lot longer than we have, and they have this. They have great terrain for like putting stuff up on these towers on the ridge lines, and then everybody pointing up, and then the ridge lines are all connected together. Historically, they had this massive project, like 10 years ago, to connect all these ridge lines together. So they have this great network down there. I always refer to those folk for like advice on how to do things well, because they do things really well. But there's about, I think the number says what, 400-ish radios in our local area at this point. That's not 400 hams necessarily, because some people have more than one radio. I have more than one radio. But there's a decent community of people who are building this stuff, getting involved in this stuff, making this network bigger. And we're always interested in trying to get to places that we can't get to yet. So, for example, we'd love to get over the hills over to Half Moon Bay, but getting over that hills with a radio is hard. We need to find the right place to have two people point up and connect. Similarly, we have a long-term goal of getting much better connectivity down to Santa Cruz. Again, there are places we can connect to, but it's a long process to get permission to get radios put up on towers in just the right places so you can see just the right place and get a radio all the way through. It takes a while, but that's okay, because we're all young, we've got time, it's fine. So the software. The software is what I sort of work on day to day. At this point, I retired from actually having a proper job, and then during COVID got sucked into this. I didn't have a license before I got sucked into this. I got my ham license during COVID just to work on the AREDN software, because it sort of appeals to me in a number of different ways. So I'm a relatively new ham with my technical license only, Dave. But the AREDN project has been going a while. This is what it used to look like back in the day. This was a node, I think, was in England. It was for the longest time the oldest running version of AREDN that we could find on the network. We've tried to make things backwards compatible over the years as much as possible. We've had to change that for various reasons, but that was always the goal. But this was even a year ago. It's 2025 February, right? This was still up. This was still running this old software. Software back then was a lot more limited what it could do. It was very simple. Over time, more and more sort of features were added to try and make the software both easier to use, sort of more informative on what was going on, to let people who wanted to tinker with it, and just let it do more. So today it looks like this, which, as you can see, is a lot more going on here than there was in that first picture. And despite this somewhat overwhelming view, the software itself mostly does everything for you. I mean, you can tinker, you can play with stuff, you can tweak things, but pretty much all you have to do now is you put our software on your radio, you look at a map to work out who you can see. The map will tell you what channel to put your radio on. You'll set that, and then that's it. That's kind of all you kind of need to do, and everything else will configure it for itself. You can then do more, but that's all you need to do to get online. I'll highlight a little bit of it. The sort of the main thing you ever have to do with this stuff, the only thing you really have to do with this stuff to get going, is setting up your radio. So we're talking to a mesh. We're on channel 181. We've turned the power up to 27 because that's as high as it goes, and we set our bandwidth to 10 megahertz, which everybody uses around here. There are options, but everybody uses 10. And in this case, we've told it what the antenna is. It doesn't care. It's informative. It helps people understand what you're doing, helps people learn things. But basically, all you have to do is set your channel, set your power, set your bandwidth, point at somebody else, and off you go. That's the only sort of box you kind of care about. And once you've done that, this box populates. This tells you what your radio can see. So this radio is one up on San Bruno Mountain here. It points down. Basically, it's the radio. Is it the radio that points here? Yes, it's the radio that points over here. Which points to the on top of the roof. Yeah, San Bruno City Hall.
Yep.
So it basically gives you a summary of what radios it can see, how good the connections are. It gives you some idea of how good the signal is, what the error rates are, how many megabits you're getting through these connections, how far these radios are from you, which it turns out kind of matters. The speed of light turns out to be quite slow when you care about high-speed data. So knowing how far you are to the other radio does matter. But this just auto-populates. It tells you what's going on. It tells you what your radio can see, how well it's performing. It gives you an idea that if you're trying to point at just the right spot, it gives you an idea of when you're doing better, when you're doing worse. You can also dig down and get a lot more information out of this kind of stuff. If you really want to know how you're doing, it will tell you the transmission rates and receive rates. It'll tell you what the other end thinks your signal's like, how good it sees you, because that also matters. How well you both see each other. Gives you an idea of how much the connection is being used. It just gives you graphs of signal over time. It tries to give you as much data to try and take a connection from it working to it working well. And also, people like data. So a lot of people look at this data, looking at it over time to try and understand how the characteristics of their area might change. Like we've had various situations where overnight certain things will be different. We've also had situations where we couldn't understand what was going on. I have a link and we couldn't understand why when it rained it was really good, and when it wasn't raining it wasn't great. Turned out that when the tree got wet, it sort of went down, and the signal was better. It's like, okay. We also used to have radios on what's the heck is the boat called? The Hornet, yes, the Hornet. We have radios on the Hornet, and that used to be great as long as the cranes were in the right place. And if the cranes would move, then nothing now. So, it helps you understand, particularly over time, how your environment might change, and what might make sense, and what you want to do differently, and what you might want to change. But that's sort of But you've already got connected at that point. Yes.
What is the hidden nodes?
Hidden nodes. Hidden nodes is a Wi-Fi term. Basically, it's when two radios are talking to a third radio. And those two radios can see that third radio, but they can't see each other.
Is that due to the directional?
It could be due to directional. It could be due to the fact that in my case, for example, there's a bloody mountain in the way.
Okay.
So, but it sort of matters because if they're both transmitting and they're trying to do it at the same time, they'll collide when they, at that point, and therefore that won't be able to receive anything because they're interfering with each other. So the hidden nodes thing is hidden node is basically identifying that that's a problem, and then it tries to adjust the communications protocol to make it less of a problem. Basically, it falls back onto the can I transmit? Yes, you can transmit. Okay, I'm transmitting now. Now it's your go kind of thing.
Okay.
So that's what the hidden node thing is. But it's less efficient. So the software will detect it for you and enable it so you don't have to, because you don't want to turn it on unless you have to, because you're gonna lose some bandwidth for that. So I mentioned this earlier. There are plenty of people who like to use AREDN, but they can't necessarily get a radio in their house because they're not allowed up on their house, Dave. They they, even if they could get on their house, they can't yet see another node to connect to. Right. So, so a long time ago, Arden introduced the notion of a tunnel. A tunnel is basically just a connection across the internet. That's all it is. It connects one Arden radio to another Arden radio across the internet. And it's not a very radio solution to the problem, of course, because there's no radio involved. But it is a good way of getting involved when you're starting out. So there's a group in Turkey, and they, one of the Arden board members gave a talk to their radio, like over the internet, gave a talk to their group like a couple of years ago, I think it was. And suddenly this network appeared in Turkey of all these Arden folk. And when they started out, it was all radios with tunnels to each other. And over time, it's been kind of interesting to watch as those links, those internet links have been replaced by actual radios pointing at each other. So they started out getting people involved by having people tunnel because that was simple. And then as people got more interested, they started to replace it with actual radios. So that was their sort of path from nothing to having an Arden network. But so we have people on our network who people having, I think there's at least one chap up in Half Moon Bay who has a tunnel because he can't see us. We have a guy up in, oh my goodness, where is it? It might be Weed, California. It's way the heck up there. And he's got no network, but he wants to participate. He comes to Pacificon every year, really enjoys doing the Arden stuff. So he has a tunnel connecting because there's just no one in his area who's doing that. I'm not sure there's anybody in his area at all. But that's how he participates in Arden. One day he might have a neighbor who could put radios up, and they will, and that would just join us, become part of the network. But that's how he gets involved. I talk about, yes.
Are there other networks that are similar to Arden that you are compatible with, but they are separate? They're their own network?
So there's a big project in Europe, mostly Germany, I think, where I'm blanking on its name, unfortunately, and they have their own network stack and protocol stack to build out a network in quite a lot of Germany and a bit of Switzerland, I think. And I don't remember its name, but it's a similar concept. We're compatible in so much that ultimately we are an internet network, right? How it's constructed is our own thing, but ultimately at the end of the day, you're moving internet packets across this network like you are across any other network that we all use every day. So you can have our network and can sit next to somebody else's network. You can have traffic go from our network to their network and their network to our network, but they have to be using our software to talk to our software. If that makes sense.
So you can't speak to those other networks that are in Germany and in Europe?
No. There are other Arden networks in Europe that we do talk to, but not other people's networks. It's not impossible. It could be done. It just we don't have the software to do it currently. I talk a lot about when you set up, you point and it connects, and that's great. It's simple, but but then there's the question of, well, can I make it better? Can I find a better place to point? If I move because this is very directional, moving the antenna just the right place might get you a better connection. So we try to provide as much tooling as we can to make that simple. The example I have here is a trace route, which is a standard sort of network thing where you basically say, I'm starting from this point. How does my packet get from here to here? And it gives you some idea how your data is crossing the Arden network. Here there's 12 hops going from, in this particular case, San Bruno Mountain to Hellsberg, which is way the heck up there, right? And it shows you how it crosses the network to get between those 2 points. And this is useful for a number of things, but from a network perspective, it's really useful to understanding where the bottlenecks are and where the signal points of failure can be. You want to build a robust network where if any one of these nodes goes down, it will go around and your data will still get through. And it's good to try and understand how your data moves through the network to understand where your weaknesses might be. And this helps you do that kind of So you built yourself an AREDN network. How the heck? I mean, great, but how do I find stuff, right? So AREDN keeps every node knows, firstly knows about every other node, and it knows what those nodes offer, what services they offer. I haven't really talked about services very much, and we'll talk about some of the options at the end. But one example, but basically there's a page on AREDN which tells you this is the network and this is everybody on it and this is what they're doing. And the biggest thing people tend to do on these networks is cameras, because cameras are kind of fun and they're very easy to put an IP camera up. They're dirt cheap on these networks, and then people can look at your cameras. There's a camera on top of my house. You want to look out across Berkeley, look at the fog. You can absolutely do that. But that's what a lot of people do that, and so AREDN will keep basically a database, a real-time database of everything it can see on the network, and we have software that keeps this all synchronized and stuff. The page itself will give you some idea of how far away it is, because the more hops, the less likely you are to get to the other end, because the more radios you're going through, it only takes one failure before, which doesn't have an alternate route where it won't get there anymore. So it gives you some concept of how likely you are to get there, how much bandwidth you're likely to have to get there. Yes?
Are there any standards for naming things?
Well, we like people to put their call sign at the beginning, but like is about as tough as it gets. No, really.
It's when we've done this, it's been hard to figure out, okay, what's a camera? People don't necessarily call them.
So when we redid the software a couple of years ago, we added these little, I don't know if you can see them on this thing. These are these little icons on the end of some of the names. And we did add some icons so people can basically pick a camera icon on when they create something. So even if they call it, thing 123, which means nothing, they can at least have a camera icon on the end so you could see camera. And then if you search, it has a search box at the top. If you type camera in that, it will find all the things with the camera icons. So we try to improve that for people without forcing them into a particular naming convention. We take a very, beyond asking people to put a call sign at the beginning of their node, which seems like a basic amateur radio requirement, we try to not be very prescriptive about how it's used, because different groups use these things in very different ways. And just because I think you should do it like this, what the hell do I know, right? I mean, I'm not in your environment. I'm not in your group. I don't know how you choose to do things. That should be up to you, not to us. We also have a mobile UI these days. We didn't used to. It used to be like a very, very tiny version of the desktop UI, which is impossible to use. But surprisingly, when you're setting up radios, you tend to be on the top of a tower and not with the laptop. So we did a handheld phone UI so you could actually use this stuff when you're up there. It's quite useful. Again, the tools are also available in this thing, so you can get powers and signal strengths and stuff when you're on your phone. Yes.
Can you get the signal strength tone?
Yes.
Awesome.
Yes, you can.
So you could use this to help point your antenna on your roof?
Yes.
Oh, okay, cool.
Yes. I still discovered I need 3 hands to do this, but still better than trying to hold the laptop. So now what? I mean, this is sort of an interesting problem that AREDN has. AREDN builds out a network. It's an internet, essentially, a private internet. A friend of mine calls it pirate internet, but that's because we're going to DEF CON in like a month, and that seems the appropriate sort of terminology for DEF CON, right? But it's an internet. You can use it for whatever you can use an internet for. So then the question becomes, what do you use it for? And people do a lot of different things. So I try to gather up a bunch from not just around here, but from other places. The obvious one is phones. People use voice over IP phones. There are lots of voice over IP exchanges on the AREDN network. A lot of the AREDN networks exchanges connect together, so you can basically make a voice over IP over an AREDN network to another AREDN network. That kind of stuff. That's quite popular. Messaging, we have various messaging apps. There's a messaging app called Raven, which you can install in your node to talk to all the other AREDN networks. It also talks to Meshtastic and Meshcore, so you can talk to those folk as well. video conferencing. There's a group down in Southern California. Every Wednesday night, I think, they have a video chat. You know, they have these tiny little windows of people talking to each other. It's not it's not Netflix, but it definitely works. Video monitoring is very popular. A lot of people will put cameras, not just because they want to look at lovely views, but perhaps they want to, to have they want to use them for security at their site, for example. A lot of people have AREDN at a site that has a lot of other stuff. They use AREDN for the cameras so that they can have surveillance. Again, the Southern California folk have used their cameras for fire monitoring and also feedback when there are active fires in areas where otherwise there'd be no cameras at all because there's no network. But there is an AREDN network and there are cameras, and that information has been provided in the past. I have a seismograph at my house, which I sort of feel is kind of stupid because I live in Berkeley. Of course it moves, but it's kind of fun, right? If there's an earthquake, you can go to my house and you can click on it, and it will show you how much of a peak it saw and all the rest of it from basically from my basement's perspective, which is kind of fun. Flight tracking is quite a popular one. People put flight trackers on the internet, but people put flight trackers on AREDN, so you can look at all the stuff came in San Francisco or in Hawaii, for example. There's the AREDN folk over there have some stuff there as well. One of my favorite ones is there's a guy up in he's in the Sacramento AREDN group, and he pulls down images from weather satellites. That's his big thing. He likes to do that. I'm really interested in that, but I would never set up that kind of equipment to do it.
Tim, how did the folks in Hawaii get the connection?
So they have their own little radio network, and then they have a connection across the internet to us.
Oh, okay.
So that's
A tunnel.
yeah, they have a tunnel. There's a particular kind of tunnel. I can talk about that. It's not part of this presentation. I'm more than happy to talk about it because they don't want to be, because Hawaii is not part of our network.
Right.
Yeah. Dave.
One item that you probably should put up there is weather stations,
It's true, I should.
because I know that I have one in my backyard and you have one up on San Bernardino Mountain.
Yeah, it's still working despite the weather up there. Yes,
I see all this it's in the clear, right? There's no encryption.
there's no encryption there. It's all in the clear. Yeah, people get. It's becoming increasingly difficult to do things in the clear. The browsers in particular would really, really, really like you not to do that. But yes, it's all in the clear. We don't enforce that because I say I'm not responsible for how you want to use your network, how you want to use your radio. That's up to the group. That's up to the local area. But obviously that's what you should do. But the satellite image guy, he pulls down all these weather satellites. He puts them on his server. The server's on AREDN. I get to browse all these cool satellite images, which I like. I mean, I kind of like that because it's an amateur radio project that I can't do, but I can still sort of take part, and I get to take part over amateur radio because I'm using the AREDN network. The internet never touches this, right? So it feels very about what the hobby should be to me, at least.
What license does it take?
Technician license. See, Dave wants me to get a better license.
Dave wants everybody.
If he gets a better license, I'm not going to have a one thing I can bug him on. At the moment, I'm happy about this.
But the thing I got my technician license to do this because this sort of interested me, and at least part of the reason I've not bothered to upgrade is because I like to be able to stand out in front of people who are interested and say, the only license you need is this one, the easy one, the high school physics and remember a few rules kind of license, right? And I like the fact that, I'm sure I could still say that, but it's nice to be honest about it. Say, this is all I got. This is all you need, right? I feel it helps to lower the barrier, and that works for me, right? So, these are some links to resources. The main AREDN website, which is run by the AREDN 5013C on mesh.org. If you're curious and you want to understand why AREDN is 12 years old and not older, if you ever go to, I think it's AREDN.org, you'll find somebody ranting about how AREDN is terrible. That's always good laugh. But AREDNmesh.org is our URL. The wiki bayaremesh.us is our local group. Our wiki has a lot of information about radio choices, links to maps, links to other information, steps to getting set up, steps to install the software, lots and lots and lots of information just getting you started. The YouTube video, which we are going to redo at some point when we get around to it, is a review of the current UI. It has evolved a little bit since we made that video, which is probably a couple of years ago now. There's a plan to redo it as a bunch of like little small videos about each little feature of the UI, so people can like just watch what they're interested in. But apparently I need to do that and haven't. There's a local Slack. Well, I should say local. There's a global Slack channel for which a lot of AREDN groups, people from AREDN groups participate in. It's a really good resource. People answering questions. People who can help you make selections about hardware, whatever you may need to do. I should also say there's a forum on the AREDN.mesh as well, with a whole bunch of helpful people there who can answer questions. A lot of information. The thing we find the problem with the forum a little bit is that the forum has messages going back a decade, and a lot of things have changed in a decade. So you have to be careful about looking at really old information on the forum. The people on the Slack will answer your questions based on current knowledge, which can be more helpful. And then finally, there's the world map. This is a map that shows you not just a little bit that I showed you of our local area, but will show you all the networks around the US, around the world, and also you can see that they're connected together. So you can actually, if you join your local AREDN mesh, you can get to stuff in Hawaii, you can get stuff in the UK, you can get stuff in Turkey, you can get to the one guy in New Zealand. There used to be a node in Antarctica base as well, but I think that guy moved, which is a shame. But yeah, you can actually see what other people are doing in AREDN, not just here but around the world. So anyway, that's the sort of general AREDN thing. I can answer questions about anything. Yes.
I saw in the beginning of your presentation, one of the slides said that AREDN helps prevent errors from happening. What are some of the errors that would happen before AREDN was created? So the group who came up with this, I mean, these are as Dave would tell you, I'm not a proper ham, right? I only have my technician license. But the people who came up with this, they've been hams for decades when they came up with this, and they were acutely aware that when people were relaying information using voice, particularly with complex information, errors would creep in because people make mistakes. So part of their goal was to be able to transfer information without the human getting in the way and making errors. So they want to be able to transmit, forms or whatever over a wireless network efficiently, quickly, and without errors. So that was the sort of errors that they were thinking about back then. Thank you.
So many of us can see San Bruno Mountain and can direct an antenna in that direction. Would that be a pile up?
No.
Okay.
I mean,
everyone's pointing at the mountain.
If 100 of you do it, then sure.
Okay.
But at this point, no. I mean, yes, obviously there's a bandwidth limitation eventually.
Okay.
But at this point, we're not even close.
Oh, okay.
And you were going to talk about higher power nodes.
So yeah, so sometimes we talk about repurposing hardware. Sometimes that's not possible for what we want to do. So so we have some links on our network which are not AREDN links. They use, so for example, some of it uses 60 gigahertz radios. So we just use those radios as a pipe. So AREDN goes into the pipe, comes out the other end, and drops down to another radio. So we're using these sort of high bandwidth or high power radios. There's some 10 gigahertz stuff, not up here so much, but there's some 10 gigahertz stuff in Southern California, which is the same. They're just using the commercial stuff that it comes with and piping AREDN across it. Because we don't have software for those radios, it makes sense to just use them with the software that you buy them. I mean, the 10 gigahertz stuff is you're spending like $5,000 per side of a link. So we just pipe hardened across the manufacturer's software. It's a slightly different setup. And so when you see those red dotted links, that's what you're seeing. You're seeing these alternate radios which are connecting certain things together. They have some advantages over our software. They have some disadvantages over our software, but mostly it's a question of this is the radio that will do the job here best, and we don't have software for it, so we have a way of just using that stuff.
Down to the nitty gritty, what kind of power requirements? Would it behoove you to have a backup power if you're having AREDN in the event of an emergency?
Oh, you mean like actual like wattage sort of
Yeah,
thing?
well, I mean, yes. Is it at 12 volts? Is it?
So almost everything that I've talked about today is 24 volts.
Okay.
I would say, so most radios run under 7 watts. They usually, if you look at the specs, they're usually way higher than that, but I've never seen them go over 7 watts.
Okay.
So that gives you some concept of how, I mean, obviously when it's actually really sending a lot of traffic, that's going to be a little higher. Most of the time it's idle. So that gives you some idea about how much power you're going to use there. So comparing that to a high power rig, so it's not very much.
Not much, yeah.
Comparing it to a Meshtastic node, it's quite a lot more.
Yeah.
So it sort of sits.
So you need 24 volts, a couple of amps.
One of the first things, when I first got involved in this project, I said during COVID times, one of the first things I fixed was the fact that we used to have something called network storms, where packets would just go around the network. People are aware of how network stuff. Often packets will have like a count, where the count will go down. Eventually, if it reaches 0, they'll throw it away. And the count starts at 255, and it would get to the state where packets would just go round until that count went down. So it would just the network would fill up with junk until eventually it would just all time out and go away. And one of the first things I fixed when I started working on this was like, that sounds really bad. Let's fix that. So we fixed that. But the big fix was to change the protocol to something that just doesn't. So we've put a bunch of effort recently into. It was on one of the slides earlier, and I just didn't talk about it ever again. 900 megahertz stuff. So, because the world of wireless protocols, I guess, is really slow. About 10 years ago, there was a proposal for a Wi-Fi network on 900 megahertz, which is ccalled Halo, or 802.11ah is the sort of designation for it. 10 years later, chipsets are available for this stuff, and people are selling chips to do this. Mostly coming out of an Australian company, in fact. But it turned out that the Australian company is based in Sydney. They're very into open source. They want to make stuff available to people to use. It turned out the guy in charge of the open source lives down the road from me in Berkeley. I'm like, oh. So we had coffee. He gave me some hardware, and now we support the Halo stuff. So the advantage of the Halo stuff is it goes through trees. 900 megahertz will go through trees a lot better than anything else we have. The disadvantage is it has less power, and the Fresnel zones are massive. So it's quite good for short distances, urban distances where trees are a problem. So I recently set up a link between me and a ham just 2 miles away. We actually have a decent path, but there's 5 years ago we had a really solid link, and the trees have grown a lot in that time, and now it's not so good. So it seemed like a good experiment to put a Halo link between these two spots, so we can experiment with how well that worked. That's the most recent sort of hardware changes we've made. In fact, the current version of the software was released in January. The next version of the software will release probably next week. And that has a lot more of this 900 megahertz radio stuff built in. There's one manufacturer that makes the chips, a whole bunch of device manufacturers that make devices you can get, including some very nice sort of tube-shaped devices which are waterproof. So you put an Omni on one end, you put the Ethernet on the other end. It's all waterproof. You can stick it on your roof. It's what I have on my roof for this test. So that's probably the most sort of interesting development, sort of spectrum-wise. There's also Wi-Fi standards because we're piggybacking on Wi-Fi stuff. We're using our own software, but it's still Wi-Fi down there somewhere. Chipsets are evolving. Speeds of chipsets are evolving. There's different standards. We use something called AC radios mostly, 802.11ac. There's also 802.11ax, which is not even the current one, but it's the next one from us. We're starting to support some of those radios now. There's not a lot of choice. There's like one radio that you can buy that we support, which is outdoor rated. Everything else is for home use essentially. And that's fine, but mostly we want stuff you can put up on a tower. So it's like one radio you can buy. But you can buy one radio and it works. And in theory, it should have much better bandwidth, particularly at short distances. So a couple of miles, you might be good. Some of our, I mean, our longest link is 50-ish miles. The dishes are very big. But you know, I wouldn't advise anybody to do that because aiming those things is just a nightmare. But it's doable, right? But these AX radios, they're much more designed for 2 or 3 miles, short distances, kind of stuff. So good for a community, not necessarily good for like pointing between mountains.
I think we're close, but I'm gonna get a point across right now. Thank you, Tim, for coming over here.
Oh, awesome,
Yeah.
thank you, yes.
So one of the